Welcome to Similar Triangles. So this is where we're going to be looking at similar triangles and calculating missing dimensions. So you can see there's one here and one over there. It says for each pair of similar triangles, identify the similar triangles and calculate the missing lengths using a proportion. So first thing we need to do is pick how we want to label this triangle, right? Triangle ABC is similar to triangle DEF. So we don't need to worry about the angles. So this one is clearly going to be easy to identify or to calculate just by looking at it. So you can see how we have 6, 8, 10. And then over here we have 3, 4, and oh, I wonder what. But we need to set it up as a proportion, and that's because one of the reasons is because they're going to get a little bit tricky. So we don't need to worry about enlargement or reduction, and there are many ways to correctly set this up and also many ways to incorrectly set it up. So my suggestion to you would be to decide whether you'd like to have the dimensions for the large triangle in the numerator or denominator, doesn't really matter, and then just be consistent. So here's what we're going to do. We're going to take 6 from this one and 3. So I like to say, so I'm going clearly, and I'm only going to draw it for this one, clearly I'm going large over small, right? So 6 is to 3 as 10 is to x, and I don't need to worry about the other ones. And that is also, so I went large over small. And so now what we'll do is we'll cross multiply. 6 times x is 6x, 3 times 10 is 30, and x equals 5, and oh, there are our units. So we're good. So next one. So the first scenario, we're going to do 2 of those, is when the triangles are separate. So you can see that clearly, right? This one is separate from that one. So we can't quite fit it all in. So hopefully you're looking at the paper. So triangle MNP is similar to triangle QRS. There we go. So now we'll go X is to 1.3, just like 6 is to 1.8. So we'll cross multiply. X times 1.8 is 1.8x. 6 times 1.3 is 7.8. And we get a fairly weird answer of 4.3 repeating units. And we can look at that and ask ourselves, okay, is that a reasonable answer, right? Because we can see, right, with this 1.3, we can look at that and say, yep, that's reasonable. So the next scenario is when the 2 triangles are attached by a point, which you can see, and I guess it'll be nice because we can see almost the whole thing in this diagram. So my suggestion, and this is how I'll teach it, is I usually rip out a piece of paper and kind of make it triangular. You can cut it out if you want to. There's nothing wrong with that, because sometimes students find it hard. Some are very good at it, to be able to rotate that to see which point lines up with which other point. So I'm going to start with triangle ABC, right? It's similar to, so if I were to take this and rotate it, A would land on top of D, B would be E, and of course C applies to both triangles. So you can see how C has to occupy the same, in this case, last spot or middle spot or first spot. So now we're going to do more than 2 equivalent fractions. We're going to do 3 here. So I have to make sure to give you one fraction that has 2 numbers, otherwise we can't calculate it, right? So I can see that it's going to be this one and this one. So 4 over 6. So now this time you can see I've decided to put my small triangle up top and the big one on the bottom. And as long as I'm consistent with that, it'll work out just fine. Okay, so 4 is to 6, just like y is to 12. and 7 is to x. And it doesn't matter if this one's in the middle, it's just students usually find it easier to cross multiply. But if the 4 over 6 was here and the y over 12 was there, you can cross multiply this way as well. So we'll do this one, 6y equals 48, y equals 8 centimeters, 4x equals 42, and x equals 10.5 centimeters. And the last scenario is triangle inside a triangle, right? So hopefully you can see the two triangles, doesn't matter which one we pick first. So we'll go triangle this time. ABC is clearly not a triangle, it's a line segment. So we'll go ABD, ACE, okay? So what I usually like to do, and I only do it for the first one, is I kind of break it down into 2. So I kind of go like this. Not my best triangles. I'll move over here in a second. Okay. And so that's what we want to compare to, right? So we want to be careful when we have a triangle inside a triangle that we don't start using just measurements from the trapezoid, because we can't compare a triangle to a trapezoid, right? Trapezoid has 4 sides and 1 pair of parallel sides is how that works, right? So, but we can transfer this over here and this over here, right? And clearly this bottom side is this one. But what will this entire length be? Well, 45 plus 22, right? So now we're ready to set up our proportion. So it doesn't matter, right, if we go this side to this side or this side to this side. I'm going to put my small one on top. 31 is to x, just like 45 is to 67. Again, dealing with larger numbers, but we can totally handle that. And x equals, whoops, no, not what I meant to put. 2077 divided by 45 is 46.15 units. And that's the end.